Welcome back to another video on limits. So now this is continuing what we learned on the last video, and on the last video we learned about how limits can help us approximate numbers and see the curves on a graph, right? And today we're going to talk about the different methods of actually solving these limits. The first method we already saw was using graph, or using a table, or even just doing direct substitution. Now, things get a little bit more complicated, and in this case, we have something called factoring. You've heard that from Algebra 1, Algebra 2, Geometry, all those kinds of math topics, and in this case, we're going to try to incorporate it into limits. So now, let me give you an example. Let's say you have the limit as x approaching 3 of x squared minus 9 over x minus 3. Now, take a moment for yourselves and think about it. Assuming that you just thought about what's happening, you can tell that it's going to turn out to be 0 over 0. So, this is what we call undefined, or also the indeterminate form of 0 over 0. So now this really just tells us that at that point we don't know what's going on. So it could be an open circle, right? And quite literally in this case, you have some kind of missing piece going on because you got a denominator as a separate function than the numerator. So now, how do we actually solve this? So now we have to use something called factoring. And in this case, in like calculus, AP, we have to state that, oh, it's the indeterminate form of 0 over 0. Some teachers do it differently depending on where you go, but the baseline is that you have to declare that it's indeterminate of form of 0 over 0. So one way that you can represent that is the limit as x approaches 3 of x squared minus 9 equals 0, and then you put the limit as x approaches 3 of x minus 3 equals 0. So you can just write the indeterminate form of 0 over 0. Now that's what we show on our first step. But in this case, we know, hey, we got to do some factoring, right? So now, by taking a look at this function right here, the top function is x squared minus 9, and the bottom function is x minus 3. Right, so now we have to think of a certain method that we can use so that we can both factor it so that we can also cancel that out. And in this case, something that really makes up the time is the limit as x approaches 3, because we always have to write that first section before we do anything else, unless you are already substituting in that case. But we can write x squared minus 9, it's a perfect square, so now we can just write it as parentheses x minus 3 times x plus 3. Looks a bit familiar, right? And of course it's going to be over x minus 3. So now we're taking a look here. I see two, let's say we have three functions here, right? Like x minus 3, x plus 3, and x minus 3, right? We have two functions that we can cancel out right away. And that would be the x minus 3 on the numerator and the x minus 3 on the denominator. So now, what does that ultimately lead us to? Always remember to write the limit first. X 3. That becomes x plus 3. So now, in this case, of course, 3 plus 3 equals 6. And that is our complete answer. So now, that is our whole entire trick that we have. And The reason why we have that trick is because we're trying to see what is there that we can actually do to figure out what the specific answer is, right? So now we're gonna try another problem, and let's see. The limit as x approaches 2 of x squared minus 4 over x minus 2. Now take a moment to figure this out on your own. It's the same exact way how we always do it. Well, hopefully you just solved it, and we can clearly tell, hey, we gotta do some factoring here, right? I'm not gonna go over the whole entire, I'm not gonna go through this whole determinate form process, but you guys understand it. So now, we're gonna try to solve it now. And this is gonna be equal to the limit as x approaches 2 of x minus 2 times x plus 2 over x minus 2. And that, of course, the x minus 2's are going to cross out. So that's going to be limit as x approaches 2 of x plus 2, and that ultimately leads to 4. Quite simple, right? So now, what if I gave you an example that was a bit harder, and that literally just leads us to our next way of solving limits. And that specific way, some people get it wrong most of the time, but of course it's good to realize it and understand it truly. Okay. Alright, whilst we slow down a bit and scroll it up, we can talk about conjugates. So now, when solving limits, we can also have radicals, right? It could be possibly anything. And the issue with radicals is that sometimes it doesn't really come out that well, right? So now, think about this. I'm gonna write a problem here, which is the limit as x approaching 4 of the square root of x minus 2 over x minus 4. Now, take a moment for yourselves and think about this. Well, hopefully you guys thought about it, and we can tell that, hey, it's 0 over 0, right? It's very self-explanatory. So now, just to write the indeterminate form of 0 over 0, the limit as x approaches 4 of the square root of x minus 2 equals the square root of 4 minus 2 equals 0, right? Because 2 minus 2 equals 0. And then the limit as x approaches 4 of x minus 4 equals 4 minus 4. Of course, that equals 0, so that's going to be indeterminate form of 0 over 0, right? So now, we got to figure out what can we do to even get the answer out here, right? And that's where this special technique comes in. We call this the conjugate. And the whole point is that we're trying to cancel out the radical. We're trying to square it so that it becomes a whole different thing. So now, by taking a look at this radical, we can tell that, hey, what is a conjugate even? It doesn't click in my head, right? So now a conjugate, it's basically the way how we reverse the function that has a radical in it. So in this case, we're gonna have to multiply by the top and the bottom, right? We're gonna try solving this out now. The limit as x approaching 4 of the square root of x minus 2 over x minus 4, and that'll be, of course, times by the square root of x plus 2. We do that, the plus 2, to basically reverse it, right? And of course, we're gonna put it at the bottom as well, x plus 2, right? So now, this would equal to the limit of x approaching 4 of, well, square root of x times the square root of x is always going to be x, right? So we can write x, and then negative 2 times the positive 2 equals negative 4 over, and then you just got x minus 4 times the square root of x plus 2. One common mistake that I see students all doing is that they basically just what's it called? They distribute it, right? They distribute the bottom denominator, right? And the reason why we don't do that is that because we see something so simple there that we can cancel out. We see the x minus 4 on the top, and then we see the x minus 4 on the bottom. So those we can cross out immediately. And you know what that brings us to? The limit as x approaching 4 of 1 over the square root of x plus 2. So now, we can now actually solve this now, because it won't be undefined, it won't be indeterminate form of 0 over 0. So now, 1 over the square root of 4 plus 2 equals 1 over 2 plus 2, and that'll ultimately equals 1 over 4. 1 over 4 is our answer, and that's how you do conjugates, right? So now I'm gonna show you an example so that you guys can try it by yourselves, and let's see how it goes. Alright, so the example here we got is, let's see, I'll make this red now. The limit as x approaching 1 of square root of x plus 3 minus 2 over x minus 1. Now pause here at the video, take a moment for yourself to figure this out, and see if you can get it on the first try. But if you don't really get it, then we'll review it together. Okay, so we have this problem, right? We know it equals to 0 over 0 at first, right? Because we got the square root of 1 plus 3 minus 2, so that's going to be square root of 4 minus 2, and 2 minus 2 equals 0, and then you got the x minus 1, assuming x equals 1, 1 minus 1 equals 0, right? So now, what can we actually do to make it so that we get the exact valid answer that we want? We don't want 0 over 0, right? So now, conjugates, again, right? It's the same thing all over again. So, in this case, we can write it as the limit as x approaching 1 of the square root of x plus 3 minus 2 over x minus 1, and we're going to multiply that by the square root of x plus 3 plus 2 over the square root of x plus 3 plus 2. Keep in mind that I didn't change anything inside the radical. That's because we're technically not supposed to change it in the radical, or else it wouldn't like combine well. So we're trying to get rid of the radical. That's the whole entire point that we're trying to do. We're trying to get rid of the radical so that we don't have to worry about some random radical in the numerator causing us to get 0, right? In this case, it becomes a little bit easier now. It'll become the limit as x approaching 1 of x plus 3, and of course you got the minus 2 and the positive 2, so that's going to be minus 4, right, over x minus 1 times the square root of x plus 3 plus 2. Now keep in mind, do not, I should write this in red now, do not distribute. Okay. We're gonna write it down here now. Distribute. Okay? Do not distribute. I ran out of space. Do not distribute. That's the one mistake that everyone makes, and it becomes something really bad, right? So now we're gonna quick this up a bit because my pad is about to like run out, and it's gonna equal to the limit as x approaching 1 of x minus 1 over x minus 1 times the conjugate, and that'll be equal to the x minus 1's cancel out, so that's the limit as x approaching 1 of 1 over the square root x plus 3 plus 2, and that's going to be equal to 1 over the square root of 1 plus 3 plus 2, and that's going to, of course, eventually lead up to 1 over the square root of 4 plus 2 equals 1 over 2 plus 2 equals 1 over 4 overall. So now, that's your answer. See, it wasn't that hard. So, as a takeaway, we can say that today we learned about the different ways of solving limits. We solved them by factoring at first, and then we solved them by doing the conjugate. The conjugate, always remember, do not distribute, and that anything inside the radical should be the same thing, and of course the operation outside of the radical is different. So you guys can do some more practice, hopefully, going on afterwards, and I will see you guys in the next video.